Nuclear fusion is a reaction where atomic nuclei are combined to form one or more different atomic nuclei and subatomic particles, neutrons or protons. The difference in mass between the reactants and products is manifested as either the release or the absorption of energy. This difference in mass arises due to the difference in nuclear binding energy between the atomic nuclei before and after the reaction. Nuclear fusion is the process that powers active or main sequence stars and other high-magnitude stars, where large amounts of energy are released. A nuclear fusion process that produces atomic nuclei lighter than iron-56 or nickel-62 will generally release energy. These elements have a relatively small mass and a relatively large binding energy per nucleon. Fusion of nuclei lighter than these releases energy, an exothermic process, while the fusion of heavier nuclei results in energy retained by the product nucleons, and the resulting reaction is endothermic. The opposite is true for the reverse process, called nuclear fission. Nuclear fusion uses lighter elements, such as hydrogen and helium, which are in general more fusible, while the heavier elements, such as uranium, thorium and plutonium, are more fissionable. The extreme astrophysical event of a supernova can produce enough energy to fuse nuclei into elements heavier than iron. In 1920, Arthur Eddington suggested hydrogen-helium fusion could be the primary source of stellar energy. Quantum tunneling was discovered by Friedrich Hund in 1929, and shortly afterwards Robert Atkinson and Fritz Houtermans used the measured masses of light elements to show that large amounts of energy could be released by fusing small nuclei. Building on the early experiments in artificial nuclear transmutation by Patrick Blackett, laboratory fusion of hydrogen isotopes was accomplished by Mark Oliphant in 1932. In the remainder of that decade, the theory of the main cycle of nuclear fusion in stars was worked out by Hans Bethe. Research into fusion for military purposes began in the early 1940s as part of the Manhattan Project. Self-sustaining nuclear fusion was first carried out on November 1, 1952, in the Ivy-Mike hydrogen, thermonuclear, bomb test. Research into developing controlled fusion inside fusion reactors has been ongoing since the 1940s, but the technology is still in its development phase. The release of energy with the fusion of light elements is due to the interplay of two opposing forces, the nuclear force, which combines together protons and neutrons, and the Coulomb force, which causes protons to repel each other. Protons are positively charged and repel each other by the Coulomb force, but they can nonetheless stick together, demonstrating the existence of another, short-range, force referred to as nuclear attraction. Light nuclei, or nuclei smaller than iron and nickel, are sufficiently small and proton-poor, allowing the nuclear force to overcome repulsion.